Hello students. Welcome to our Senior Secondary School 2 Physics lesson. Today, we will be learning about gas laws. But before we proceed, let's quickly recap what we learned in our previous lesson. In our previous lesson, we defined heat energy and temperature, and explained how heat can be transferred. We understood the difference between heat and temperature. We described the effect of heat on matter. And we also explained the measurement of temperature. Before we begin today's lesson, let's take a quick rundown of our lesson objectives. By the end of today's lesson, you will be able to explore measurements of gas pressure, define and explain the fundamental gas laws. We will also explain kinetic molecular theory of gases. Are you ready? Let's proceed. What is pressure? Pressure is defined as the force exerted on a given area. Gas pressure is caused by the force exerted by gas molecules colliding with the surfaces of objects. It is commonly measured using various instruments and expressed in different units. Units of pressure. The SI unit of pressure is Pascal, where 1 Pascal equals 1 Newton per meter squared. Atmosphere. Millimeters of mercury. And torr, where 1 atmosphere equals 760 torr. Instruments for measuring gas pressure. Barometer. Measures atmospheric pressure using a column of mercury. Invented by Evangelista Torricelli, and used especially in forecasting the weather and determining altitude. Manometer. Measures the pressure of a gas in a closed container. It consists of a U-shaped tube filled with liquid, where the difference in liquid height indicates pressure. Pressure gauge. Used in industrial applications to measure gas pressure in tanks and pipelines. Now, let's explore these gas laws. Gases are states of matter. Gases undergo a type of motion called random motion or zigzag motion. It describes the behavior of gases in different conditions of pressure, volume, and temperature. These laws help us understand how gases respond to changes in their environment. Boyle's law. Boyle's law states that the volume of a gas is inversely proportional to its pressure, provided the temperature remains constant. This means that, as pressure increases, volume decreases, and vice versa. It is mathematically expressed as P1 V1 equals P2 V2. P1 V1 is the initial and final pressures, and P2 V2 is the initial and final volumes. Example: if a syringe is compressed by applying force on the plunger, the air inside takes up less space, increasing the pressure. Charles' law. Charles' law states that the volume of a gas is directly proportional to its absolute temperature, provided the pressure remains constant. This means that as temperature increases, volume also increases. It is mathematically expressed as V1 all over T1 equals V2 all over T2, where V1, V2 equals initial and final volumes. T1, T2 equals initial and final temperatures. Example: a hot air balloon expands as the air inside is heated, because the gas molecules move faster and occupy more space. Gay-Lussac's law. This deals with the change in pressure and absolute temperature of a gas. Gay-Lussac's law states that the pressure of a gas is directly proportional to its absolute temperature, provided the volume is kept constant. It is mathematically expressed as P1 all over T1 equals P2 all over T2. P1, P2 is the initial and final pressures. T1, T2 is the initial and final temperatures. Example: a sealed aerosol can explode when exposed to high heat because the gas inside expands, increasing pressure. Combined gas law. The combined gas law, also known as a general gas equation, is obtained by combining three gas laws which include Charles' law, Boyle's law, and Gay-Lussac's law. The law shows the relationship between temperature, volume, and pressure for a fixed quantity of gas. It is mathematically expressed as P1V1 all over T1 equals P2V2 all over T2. Now, let's discuss the kinetic molecular theory of gases. The kinetic molecular theory explains the behavior of gases by considering them as a collection of tiny particles in constant motion. This theory helps justify the gas laws and provides a deeper understanding of gas properties. Postulates of kinetic molecular theory. Gases consist of a large number of tiny particles, atoms and molecules. These particles are extremely small compared to the distance between the particles. The volume of individual gas molecules is negligible compared to the total volume of the container. Most of the volume occupied by the gas is empty space. The collisions between the molecules and the walls are perfectly elastic, which means when the molecules collide, they do not lose kinetic energy. Molecules never slow down and will stay at the same speed. There are no significant intermolecular forces between gas particles, meaning they neither attract nor repel each other. The average kinetic energy of gas particles is directly proportional to the absolute temperature. Explaining kinetic theory using gas laws. Gas pressure. Gas particles move in all directions, colliding with the container walls, which creates pressure. Temperature and energy. Higher temperatures increase the kinetic energy of gas particles, making them move faster. Boyle's law explanation. When volume decreases, gas particles collide more frequently with container walls, increasing pressure. Charles' law explanation. When temperature increases, gas particles move faster, causing expansion and increasing volume. Diffusion and effusion. Gases spread out and pass through small openings without collisions due to constant random motion. Now it's your turn. Here are 2 quick practice problems. Give them a shot. Remember to pause the screen and solve the problem. Great job so far. Let's recap what we've learned. Gas laws describe how gases behave under different conditions of temperature, pressure, and volume. Gas laws are essential in science and engineering. They help us understand things like weather patterns. The kinetic molecular theory provides a deeper understanding of gas behavior. In our next lesson we will be learning more about gas laws. Awesome work! You've completed this lesson. Stay consistent, and get ready for the next lesson.